So this you are keeping. What is for definition? Dou G by dou Ni. RT and gamma, I have already done it, right? This is RT and gamma, this part. So this you can write Ni Gi bar, where Gi bar, right? Where Gi bar, which is dou Ge by dou Ni Tp in J not equals to what? So if you compare, it is coming dou G by dou Ni is ln gamma. You are getting RT, sorry, it is RT is also there. RT and gamma, you are getting RT and gamma plus some other term. So that term has to be 0 by comparing. That is gives Durham relationship. Contact clear? Rahul? Contact clear? Okay. So what you got gives Durham relationship. So activity coefficient. For activity coefficient you have summation K equals to 1 to C Nk dou ln gamma K by dou Ni equals to 0. How to show? Now I am giving a home task. How to show? Summation K equals to 1 to C xk dou ln gamma K dou xi equals to 0. This also you can show. This also you can show. Right? This can be very easy. If you write in terms of a specific property, you can do it. Okay? It's not that. So we'll be using this one. So it's now it is proved that activity coefficient satisfied gives Durham relationship. Activity coefficient satisfied gives Durham relationship. Activity coefficient satisfied gives Durham relationship. Okay. Now we have to develop the models. What we have got finally, Ge equals to RT summation I equals to 1 to C ln Ni ln gamma, right? If you write small g, what will you get? RT. Small g is very easy. Capital divide by capital N, divide by capital N, get summation xi. Summation I equals to 1 to C xi ln gamma. So you can see Ge by RT, which is nothing but summation I equals to 1 to C xi ln gamma. So all the models in the book is given in terms of G by RT. All the Margulas equation, whatever you have, is given in terms of G by RT. Margulas equation, Redlich-Twister, your uniquark, unifat, everything is given like this. So now we have to develop the models for G by RT. So G by RT is summation I equals to 1 to C xi ln gamma r. Let's say binary mixture. Most of this model is given in terms of for binary mixture, because in chemical engineering it is more fundamental. Therefore, liquid binary mixture, benzene, toluene, benzene, water, whatever. We have the multi-component. In that case, those things will be very complicated. I'll be talking only for binary. Multi-component can be done in some of the other advanced thermodynamics course that you won't be in. So you will be restricting for two components for gas, vapor, liquid, liquid. So if for the pure substance x1 equals to 1 tending to 1, and what is this gamma mix? We have proved it Fi by Xi Fi star. Okay? If x1 tending to 1, what actually happens? Of Fi, it will be Fi star And why? Because gamma is tending to 1. And what will be happening? GE by RT. If x1 tending to 1 and x2 tending to 0, binary mixture, what will be GE by RT? x1 ln gamma 1 plus x2 ln gamma 2. And x1 is 1, ln gamma means ln 1 is 0. And x2 there is no quotient, x2 itself is 0. I don't want to talk about that. So G by RT is giving 0. G by RT is giving 0 if x1 equals to 1. If x2 equals to 1 and x2 equals to 0. And same thing. Same result will get also. That means what I can say, G by RT, I can write something like that. Ax1 x2, if x1 tending to 1, x2 into 0 is giving G by RT 0. So all the both the limits is satisfying. So that's the most simplified model for the excess energy, and this model is termed as Margulas equation. This model is most simplified model is termed as Margulas equation. This simplified model is termed as, for binary mixture, is called as 2 suffix model. It is called as 2 suffix model. It is called as 2 suffix model. It is called as 2 suffix model. So now our objective is, we got the model. We have to find out gamma 1, gamma 2. Once we find out gamma 1, gamma 2, we have the BLE equation. Gamma 1, x1, p1 sat equals to y1, p. You put that by value of gamma 1, your BLE has been solved. The same problem, 40%, 60% problem, you can do by this gamma 1. Thing is to determine the gamma 1, and for that purpose, we need to have the model. So let's look at how to, after doing that, how to calculate gamma 1, gamma 2. That's very important.
So what will be the range of gamma?
We'll see. We'll see. That's what my point is now. What's the range of gamma? Okay. We have to find out from this gamma 1 and gamma 2. And as you said, what is the range of time? That's the thing I am going to discuss now. Okay. How to calculate gamma 1, gamma 2? Now we know the actual model of G by RT. From G by RT, we have the equation ln gamma I equals to 1 by RT, then what should I write? Ln gamma I 1 by RT into ln gamma equals to, you know the ln gamma formula, right? By now, ln gamma equals to ln gamma equals to what? What when GE equals to what we found? RT Ni ln gamma I, right? We have found it. What is this? This is nothing but RT Ni. We can write this as, what is GI you got? For comparing here, RT okay, this part is clear, right? What is ln gamma I then? Let's see whether you can answer. If not me. What is ln gamma I? What is GI equal? Dou G by dou Ni TP NJJ, not equals to what? Even now so you cannot tell what is ln gamma I? Now so you cannot tell? Rahul? Impossible to tell? Impossible to tell? Yes, who is giving the answer? Panda. Yes. Multiplied by 1 by RT, right? Yes, you have to write that, no? Dou GE, dou NI, TP, NJ, J not equals to 1. Any question? Understood? I don't think you understood. Did you understand? You didn't get it. It's there. First time I am seeing the very trivial thing I am not getting it. This excess free energy. It is multiplied by Ni GI bar, which is the partial molar property, right? Okay? So that means what? That will be dou G by dou energy P Nj. And from here what you see?
So you are basically comparing.
Of course. Of course, any property is given by this. Of course, you know that. You know capital G is summation Ni Gi bar. If something is given like Ni some term, you can actually say that this term corresponds to that. The same thing. So that's a property, thermodynamic property. I am not doing anything. I am not comparing. I am just going by thermodynamic property. Right? Okay. We have the model. GE by RT equals to, we are doing Margulis equation, which is A x1 x2. What will you get? GE by RT? I have to get in terms of G as a function of N1, N2, otherwise you cannot do that. Dou G by dou N. You can write this as N1 by N, N2 by N. Am I correct? Divided by or multiplied, I don't know exactly. N1 by N, N2 by N. Pardon? Okay. Then what did you get? A N1 N2.
N1 N2 by A is N1 plus N2.
So GE equals to dou GE by dou Ni TP Nj, J not equals to 1. How much? Or you can directly have 1 by RT, so that will give you ln gamma R. This is better to write that way. Ln gamma is 1 by RT dou G by dou. So ln gamma 1 first to calculate, and then I do ln gamma 2. Ln gamma 1. It will be dou G by dou N1 TP N2, correct? TP N2. How much you are getting? Dou 1 by RT dou G dou N1 TP N2. TP N2. How much you are getting?
So A into N2 by N1 plus N2.
A into
By N1 plus N2 minus N1 N2 by N1 plus N2.
Can you simplify?
In terms of moon fraction.
No. First N2. N2 N1 N2 is not simplified relationship. Only one term will be there. A into square by N1 plus N2 whole square. Okay, in terms of mole fraction then? AX2 square. AX2 square. How to calculate ln gamma 2? I don't want to go like this way. I do Gibbs-Duhem formula. I have the Gibbs-Duhem formula. Once ln gamma is determined, I will not do the same thing. I will go by Gibbs-Duhem formula. What is my Gibbs-Duhem formula? X1 dou ln gamma 1 by dou x2 plus x2 dou ln gamma 2. Yes? Am I correct? Yes, I am correct. Why I am writing dou x2? Because gamma is a function of x2. If it is a function of x1, you take x1. That's all. Anyway, Find out gamma 2 from here. So dou ln gamma 1 is x2 square. So x2 square, so it is actually coming how much? x1. How much it is coming? 2ax2, am I correct? Plus, so equals to minus x2 minus dou ln gamma 2 by dou x2, am I correct? Yes or no? Cancelled. Minus 2ax1. And minus dou ln gamma 2 by dou x2, can you write in terms of x1? Dou x1? Dou ln gamma 2 by dou x2, you can write as dou ln gamma 2 by dou x1 by dou x2. x1 plus x2 equals to 1. Dou x1 by dou x2 equals to, so it is, am I correct? Dou ln gamma 2 by dou x1. So if you integrate, what will you get? Ln gamma 2 equals to, what is that? A or B? 2a. What will you get? ax1 square. Some integration constant will be there, no? How to find out integration constant? Limit x1 equals to 1, gamma 2 equals to what? You have got a relationship right now, just now I seen, right? Gamma 1 gamma relationship here. This gamma 1. Yeah. So that means C is going to 0. So ln gamma 2 equals to, you can get the same formula by doing this one. Okay? Either way, if you do that, it has satisfied the Gibbs dual formula. Whatever. So you got the gamma 1, gamma 2. Now coming to Devon's point, what are the values of the gamma 1, gamma 2? Activity coefficient models. So if you look at G by RT, G by RT as a function of x1 0 to 1, how does graph will look like? ax1 x2, no? That means ax1 into 1 minus x1. ax1 into 1 minus, so that is coming ax1 minus ax1 square. It is a parabola. How the parabola will be like this or like this? Pardon? Where? How the parabola will look like? It will be like that or like that. And where from the parabola will start? 0. Going to 1. Going to 1 or 0? Both the point is 0 because x2 equals to 1 and x1 equals to 1. What's the maximum value? I am assuming a equals to 1. Assume a equals to 1. What's the maximum value? Maximum value is obtained x1 equals to 0.5. How much is coming? 0.25, right? Maximum value is 0.25. Ln gamma 1, gamma I am actually trying to put x1. So 1 first, if I put in terms of x1, first will be a into 1 minus x1 whole square. Ln gamma 2 is ax1 square, right? How this graph should be look like? How this graph will look like? If a equals to 1, what actually happens? At x1 equals to 0, x1 equals to 0, x2 equals to 1. So starting from 1, right? It will go to 0, right? How it will go? It is ln gamma 1, the x2 square. So how it will go to 0? It is again a parabola. It is again a parabola. This is ln gamma 1. Understood? Depending on the value of A, you have the gamma 1 values. Okay? So if ln gamma 1 is how much? x2 square equals to A will be given. I am assuming 1. Some other things will be given for different solutions will be changing. Okay? If ln gamma 1 equals to 1, how will be the gamma? E to the power 1. How much it is coming? 2 point something, right? 2.37 or something. Pardon?
How is it determined?
A will be given for the as a parameter. A will be given. Is experimental, exactly. There are a lot of papers actually there. Activity coefficient models, the active research area. Active research area, how to find activity coefficient models. This is very simple. This is nobody is doing research on that. People are going to unique quark, unique pack, and then even much tougher. Determining is a big thing. So activity coefficient you can determine from the experiment. Compare the model, you can fit, and you can see what's the value A is mentioned. Right? How to calculate the activity coefficient? Fi by xi fi square. How to calculate Fi? You know that. How to estimate Fi? If you say, okay, I have the equation of state, maybe Bain-Robinson equation of state, you can calculate the big formula Fi. Xi is known, mole fraction. Fi is the pure substance. Pure substance also viscosity coefficient, viscosity you can find out from the Bain-Robinson. Calculate, you get the gamma. Use that is the thing, estimate, and then you calculate from the formula. Just see which is actually mentioned. Okay. Next, we will be going to Redlich-Quistar equation. Another model. So this is the simplest model I have given. Margulis 2 suffix model. We will go to now Redlich-Quistar. Have you heard Redlich-Quistar earlier? No. Redlich-Quistar equation. So far everything is understood, right? This part is not that difficult. This is very easy part actually. What we have done, already done tougher than this part. So this is easy part. So Redlich-Quistar. Redlich-Quistar equation. G by RT equals to x1 x2 A plus B into x1 minus x2 plus C into x1 minus x2 whole square and so on. Nonlinear model. The model is given for some kind of solution. You have to find out gamma. Once your gamma is known, you can actually get your solution. So, how to find out gamma? You have the formula ln gamma I or ln gamma 1, which is 1 by RT dou GE by dou N1 TP into, correct? What is G by RT from here? What is G by RT from here? We have done no earlier. Multiply by n, you will get G by RT. Then x1 should be replaced by n1 by n, x2 should be replaced by n1, n2 by n. What is that? Or you can write this way, simplified form. Let's see what we can do later. A plus B into x1 minus x2 plus C into x1 minus x2 whole square. And everything higher order term. If you take this one, how to handle? Dou n1 I will take this as u and this as v. U v, ddx of uv. ddx of uv. This is u, this is v. Okay. Dou dou n1 n x1 x2. What will the term? Write down the stuff. Then we can do the next step. First, you write down what I am trying to do. Then I will use this as v du dx. It has got 3 multiplication terms, so 3 terms should become. So we will have dou n1 of n. We have x1, x2, and then entire stuff. Then a plus b into x1 minus x2 plus c into x1 minus x2 whole square over plus dou n1 x1 n x2 a plus b into x1 minus x2 plus c into x1 minus x2 whole square plus dou n1 x2 n x1 a plus b into x1 minus x2 plus c into x1 minus x2 whole square. Remember that these derivations are not any of the books. So these are privileges that you are learning in this class. Okay. So dou n1 by dou n of n1 is how much? Dou n of n1 1. Dou x1 by dou n1
x1 and x2.
what is that? x1 is n1 by n.
No, that's what we need to convert it.
Dou x1 by dou n is how much? Dou x1 by dou n1, right? Yes. What? 1 by n? Sir, we are doing dts of u by v. There is no constant here. Constant is only n2. Here constant is what? T n2. n1 is not constant for this calculation. What is dou x1 by dou n1? Dou x1 by dou n1 how much? Dou x1 by dou n1. What is that? More simplified from x2 by n. Dou x2 by dou n1. How much it is coming? Similarly, remember that ln gamma 1 you have to express in terms of function of x1, x2. It is better you are doing now itself. If you don't do, then it will be a problem. Because ln gamma 1, gamma 2, we have to draw this kind of graph, as I showed earlier. Function of x1 or x2. So you have to express in terms of x1, x2. Everything. It is better. How much dou x2 by dou n1? How much is dou x2 by dou n1? ln gamma 1. Now final step. ln gamma 1. How much? I am giving you the clues. You have to fill up x1, x2. First you tell me what is this term. I I think there is something wrong here.
So one more term will be
One more term will be there. Yes. So plus of n x1 x2 will be going there, and then dou n1 of
the whole.
a plus b into x1, because I got missed out the term, plus c into x1 minus x2 whole square. I shouldn't have written this term, I should have directly gone to this. That's the mistake was. Okay. Dou n1 by dou n of dou n1 is 1, right? So x1, x2. So what is this term? This term is a plus b into x1 minus x2 plus c into x1 minus x2 whole square. Next term will be second term, dou x1 by dou n1. You can combine these two terms, dou x1 by dou n1 and dou x2 by dou n1, because these things are same. A plus b into x1 minus x2 plus c into x1 minus x2 whole square. What is this term? Combining these two terms, there are four terms. 1, 2, 3, 4. There are four terms. And the third term will be n x1 x2, including all terms. That will come later. First we finish up this one. Yes, what is this term coming? From second and third term? x2 square? Okay, then fill up the blanks, the next one. We will get b into plus 2c into x1 minus x2. b into what? This a will be going to 0. We will get b into dou x1 by dou n1 minus dou x2 by dou n1. 1 will be minus, half will be minus, so minus plus. So what will you get? 2x2 by n. Next, here 2x2 by n. Okay, ln gamma 1. Next simplification, ln gamma 1 into equals to ln gamma 1 equals to x2 square plus x1 x2, fill in the blanks, x2 square, this term is coming directly from here, a plus b into x1 minus x2 plus c into x1 minus x2 whole square. x1 x2 is coming from here, here and here, and n getting cancelled, so no problem. How much you are getting in this bracket? How much you are getting in this bracket? x2
plus 2c x1 minus x2 plus
2b x2 is correct, not 2c.
4c x2 into
4c x2 into x1 minus x2. Okay. See, generally speaking, ln gamma 1 should be expressed in terms of function of x2. So here we have x1, x2 both are there. Okay. So what is the final form of the in terms of function of x2? ln gamma 1 should be in terms of function of x2. Generally for these models we have ln gamma 1 function of x2, ln gamma 2 function of x1. So what is my ln gamma 1? So I can give you the hints. Some terms will be there into x2 square, some terms will be there x cube, x2 cube, some term will be there x2 to the power 4. What is the coefficient for x2 square? So what you have to do, you have to substitute x1 as 1 minus x2. 1 minus x2. 1 minus x2. Okay? If you do that, and x1 also you have to substitute by 1 minus x2. If you do that, what you get? Yes. Any answer? x2 square. Pardon? A plus 3b? No. Yes. Next, x2 cube. x2 cube. Minus put minus here. I am putting minus comma. Minus 4b plus x minus 4. Last term. Last term. Very simple last term. Last term is very simple. Ln gamma 2, I'll give you the answer. You know by now how to do it. A minus 3b plus 5c x1 square plus 4b minus 4c x1 cube plus 12c x1 to the power 4. How to get from here? Dou ln gamma 2 by dou x2, dou ln gamma 1 by dou x2 plus dou ln gamma 2 by dou x2 x1 dou ln gamma 1 by dou x2 plus x2 dou ln gamma 2 by dou x2 equals to 0, and from there you do integration and do all the limits and you get this. So you have to do it at home. This is it is not a trivial. You have to do some math. So in this class, actually series of class, whatever models you will take, you won't see in the books, all the books like YBC Rao, even Kevin Arden and all the books actually I have seen, even Sandler book, they gave the formula of Engg gamma. This is the model, this is the formula. This is the model, this is the formula. We won't go by that. We have to prove it. Even unique quark, unique fact, I don't think we have proved it, right? We will prove it. Very difficult proof, and I will tell you that Sandler did a mistake in the proof, in the formula, and from the Sandler, why we see now Kevin Arden, all the books in the available in the market, they copied, they did the mistake, and I will show you that I will give you the simplified formula. What is given in Sandler is not the simplified formula. I did further simplification, but it's not available in the book. It is there only in my classroom. Thanks for your attention.